In this video, we're going to be looking at using the ideal gas law. So the ideal gas law is PV equals nRT. I've listed all of the variables, their names, their units. Pressure, or P refers to pressure with units in ATM, millimeters per mercury, and kPa. V refers to volume with units of liters. N should be a lowercase n, refers to moles. R is gas constant, and T refers to temperature in Kelvin. And I've made a little note here that R, because it's a gas constant, its number is 0.08206, so anytime you see R, you're always going to be using this number. So if you look at this law, and let's say you're trying to solve for anything here, let's say you're trying to solve for P, all you would really have to do to figure that out is just rearrange these variables in a way that you isolate what you're trying to solve for. So in the case where we're trying to solve for P, we would simply isolate P on one side and then put everything else onto the other side. So let's look at a few examples of how we're going to do that. So first we're asked, at what temperature will 0.654 moles of neon gas occupy 12.30 liters at 1.95 atmospheres? So we're going to use our ideal gas law, PV equals nRT, and we're going to determine what we already know. So we know for sure we have R, we have our gas constant. That's never going to change. We also know we have 0.654 moles of neon gas, so we know we have our N. And I'm just going to fix this check mark here. Okay, so we know we have our N, we know we have our R. What else do we have? We have 12.30 liters, which, based on the units, that refers to our volume. So we have V, and we have 1.95 ATM, that refers to a pressure. So we have these four variables here, and we don't have T. That's what we're trying to solve for, temperature. So we're just going to rearrange this law here so that we have T on one side and everything else on the other side. So using our basic math skills, we put T equals PV over NR. And from that point on, all we have to do is simply plug in the numbers. So for pressure, we determined that the pressure was 1.95. For volume, we have 12.30 liters. We're going to divide that by the number of moles times the gas constant. So the number of moles was 0.654. The gas constant is 0.08206. And when we do that, our final answer should be 447 Kelvin after we've plugged that into a calculator. So you can see all we really had to do here was plug in the numbers and determine what the final answer was. And all we did to do that was rearrange the formula. So that's pretty much all the ideal gas law is rearranging the variables in a way that you isolate what you want to find. Okay, well now let's look at a problem that's a little more time intensive. So we have 5.600 grams of solid carbon dioxide is put in an empty sealed 4-liter container at a temperature of 300 Kelvin. When all the solid CO2 becomes gas, what will be the pressure in the container? So once again, we're going to look at what we know and what we don't know. Using the ideal gas law, we know we have R always. Now if we look at the 5.6 grams of solid carbon dioxide, that's sort of referring to our number of moles. So we don't quite have it yet, but we can solve for moles. So if we know we have 5.6 grams of solid carbon dioxide, we can convert that into moles, and that will give us our N. So let's just do that. It's just an added extra step, but we're going to do 5.6 grams of carbon dioxide and use a little bit of dimensional analysis here. So in 1 mole of carbon dioxide, if you add up all the numbers of atoms here, we get 44.01 grams of carbon dioxide, and solve for the number of moles, cancel out the grams. That will give you 0.127 moles of carbon dioxide. Oh great, now we have our N. Now what else do we have? We also have 4 liters, and that's going to refer to our volume. So we have V, and we have a temperature of 300 Kelvin, our T. And all we have left is pressure. That's what we're trying to solve for. So once again, just like last time, all we got to do is isolate the variable that we want to figure out. So we isolate P, put everything else on one side, so we get P equals nRT over V. And once again, all we have to do is plug in the numbers. So for the number of moles, we have 0.127 moles. The gas constant, as usual, that doesn't change. And temperature, which is 300. And we're going to divide that by the volume, which we decided was 4 liters. And we'll plug that into a calculator, all these numbers into a calculator, and we should get a final answer of 0.782 ATM. And that's all it is. So to figure that out, all we had to do was rearrange the equation, rearrange the ideal gas law in a way that gave us P. But as you'll notice here, some problems like this one are slightly more time intensive, where we have to do a little extra work converting, for example, grams to moles. But as long as you know you have some of the variables, you can basically figure out the problem from there.